Okay, so on this machine we have our TMAC system. This is the graphical interface for it here. The machine has several sensors in it. So in this particular machine, it's a mill turn, so there's a main spindle and sub spindle. There's also a tooling spindle that is where all the rotating tools and the turning tools go into. So we're monitoring all those parts, and as the screens come up on TMAC, the particular sensor for the type of cutting that's happening will become prevalent. So when we're doing turning type applications, we're looking at the power of the main or the sub spindle. When we have rotating tools, we're looking at the power sensor on the tooling spindle. So TMAC is monitoring all the tools in the machine as they're cutting and basically determining whether they're worn or broken. There's another piece of the system called adaptive control that we're also doing on this machine, and I'm going to grab a part. So for adaptive control, as it's cutting this certain sections of the part, the system takes over the feed rate, will automatically override the feed rate to optimize the cutting. So in this particular part, the center of this would be the highest cutting level, but out here on the edges, it actually can go faster. So we'll see a cut come up that automatically takes over the feed rate of the control, and it actually reduces the time to cut that hex by about 25%. So all those things are going on in the machine. In addition to that, we have a vibration sensor on the spindle and a vibration sensor on the main spindle of the machine, on the tooling spindle and the main spindle. The vibration sensor on the main spindle can be used to measure vibration of the cutting, but also the vibration can be used to determine the health of the spindle bearings. So as the machine runs every day, week, and month, we're doing automatic bearing health by continually doing a 5-second test, say once a week. And it tells us the exact state of the spindle bearings. The vibration sensor on the main spindle is used for bar feed type applications. When you have a 12-foot bar being fed into the machine, it's going to measure that bar vibration, and if there's a problem with the bar, there's a bend or an anomaly, it starts vibrating excessively, that sensor will automatically tell the machine the vibration level is above a level that you can actually cut a good part. So it allows the machine to then reduce the RPM slightly and try to eliminate the vibration. All that is a closed loop system. It's all monitoring and controlling the machine automatically. All this data that's being collected can be viewed historically. It can be transmitted upstream to supervisory systems. The other piece of TMAC is that the screens that you see going, there's actually a web server inside the TMAC processor. So this is just a web browser. So I could use my phone right now and look at it. I could be looking at it from my desk in another office. I can look at the live cutting as well as historical values, including editing what the cutting parameters are. It's all obviously protected by different access levels, but the beauty of TMAC is you can look at it from anywhere as long as you have some network access to the machine that's on the shop floor.